uh, IME framework and IME interpretability capabilities and experiment, and the last one is for conclusion. Firstly, I'll start with the why mixture of experts. So, nowadays, ChatGPT and other large language model is very powerful and it's widely used. And recently, the Mixture AI just introduced Mixture 7 billion parameter to compete with GPT-3 Turbo, which is used for ChatGPT 3. And currently, they are most powerful large language models. And thanks to the mixture of expert techniques, and Mixture AI can reduce nearly 200 cheaper costs than GPT-4, and around 9 times cheaper than GPT 3.5. And so the idea of mixture of expert start with the motivation for the paper introduced, I remember, in 2020, and it's have a question about binding problem. Binding problem means that deep network can be like associate of subnetwork to present uh, to present for the presentation. For example, for the time series data here, it include many pattern inside the data. So how does model can be separate this pattern to be understand it separately, and it can be help to reduce complexity of model and improve the robustness and improve the explainability. Like the function here, it can be decomposed like 3 parts, like the part green part is always active, and the red part is active when the red pattern appear, and for the pink part, this will be active when the pink part appear. And this is an idea for the binding deep neural network. And it can be for two approach, it can be solve this problem. First is a competition. So this competition is idea introduced about 2014 with the compete network. For X neural inside network, it will be compete together to choose like the bigger is a better, and it's also appear using the cell organization map is one solution. And the second approach is nowadays very popular in visual expert, is a router approach. And for the router is used on the simple neural network as a router to route the token, like each token can be choose the expert here can be like fit forward neural network, and the router will be have to choose the expert for each token, and the router can be send input to the expert, and it can help to the model have specialization and reduce the computation. And router can be many kind of design for router. Here I introduce 3 type of router. First, for the basic one, the called spare mixture of expert. It uses like simple neural network. It's one layer to be a router, and the X token will be moved to this router. And the second paper, they introduce a mixture of expert dropout with a fixed router, and it can be helped to stabilize router policy, but it cannot adapt with the token representation chain. And my paper is called Hyper Router. So I submit the paper to EMNLP conference last year. Introduce a hyper network technique to apply to choose a router policy, so it can be improved compared with other method. For the we back to the interpretation mixture of expert model. So the idea of this paper to design a a mixture of expert architecture, it can be interpretable and it can be explained for the model prediction and model output. So the key summary for this paper is can be design a very high accuracy mixture of expert model compared with black box model, so like deep neural network in many cases. And this module consists two main modules. A side module is same with like router and it's mixture of expert. And the last for like this desire can premise to being integrated with existing deep neural network and it's offer the interpretability to subset of sample while maintaining the accuracy. For this detail for this framework, it's designed for type of framework for mixture of expert. It depends on the purpose. The first simple one is a single level assignment. So it's the assignment module here is very simple and it can be explainable. So in this case, the framework offer both assignment model and expert can be interpretable. And the second one is a like single interpretable mixture of expert is propose a single level assignment where the assignment module is a deep neural network and it can be interpretability for the expert. Yeah. And for the last one, for the number C is propose the hierarchical interpretable mixture of expert where both the assignment module and expert module are interpretable. In the C, it adds more than the deep neural network assignment module. And for the last one, D is propose a hierarchical interpretable mixture of expert where assignment module and deep neural network are and deep neural network and expert are interpretable. And for the detail of architecture, for this one, the sample design for single IME. Here is a expert to produce like single predict. I can see here. And for the assignment, it can be assigned to after the predict of output expert, it calculate with the target to calculate the expert errors, and expert error will be used input for the assignment module, and assignment module compare the expert errors with input to output for assignment weight. Assignment weight here will be used for the explainable model to explain which part of model is focused on or which part of model is true for. And they also propose 5 types of loss used to supervise assignment module and expert weight. And compare with single EMEs, hierarchical IMEs as a deep neural network expert here to improve the model performance. And it's also add the one module is called hierarchical assignment module to explain the weight, the contribution weight between IME and the deep neural expert. The loss, this paper is proposed the complex loss with five type loss. Yes, it's
between the first
prediction loss. Sorry.
I was saying, can you tell me the difference between the two frameworks that you just mentioned? I'm still trying to. So if you go back a bit to the four diagram. No. At the beginning, 4 diagrams. Yeah.
Beginning. Yeah.
Next one. Next one. Next. So you had like 4 A, B, C, D, different IMEs, right?
You mean this slide?
No. So you go, next one.
Okay, I know. Here. Okay.
Yeah. So I was saying like here at the first one you said like the module and experts are interpretable. So by experts you mean human expert? First of all, that's the question that I want to ask.
Can you repeat the question? Yeah, we have a assignment module here.
What do you mean by
expert? Yeah.
Is it like human? There's in the human in the loop, or is our system itself?
Expert here can be like linear regression or decision tree model or deep neural network. And for the case here, they choose like explainable expert. It's like linear regression. You can understand. You can assume this expert is a linear regression. And like expert assignment module is. Sorry, can you continue?
Yeah, I was saying like so expert is, for example, some sort of explainable model.
Yeah, it's true. Expert here is an explainable model. It's simple model like linear regression or decision tree. Yeah.
And so in that case, whenever you replace one expert with a black box neural network, you are saying it that, okay, that's the difference between A and C, for example.
A and C, yeah, it's different with the deep neural network, and it's also different like deep neural assignment module. For C, it's also add another assignment module, you see.
So I'm saying like on the right, you have like 4 experts for A, and for C, you are replacing one of the experts with the neural network, right?
Yeah, true. With the deep neural network. And to explain the deep neural network, we need to add a new module. It's called deep neural assignment module to explain this model.
This neural network. Okay. Okay. And for B, you have expert assignment module that can be the neural network.
Yeah.
And you have this.
For D, we it's C with C, but the difference is only the expert and deep neural network is interpretable. And for C, we can interpret the both assignment and expert module. So C and D different only the explainable of assignment module.
So in C, you have like the DNN module and the expert module, both of them are interpretable, right? For the D. So my question is like in the D, you are just considering it as a black box, or for the D last one?
For the D, it's focused on the explainable like expert. And for C, it's focused on explainable both module assignment and expert.
And for the D,
different.
And for the D, is it like black box?
Yeah, it's black box. Yeah, it's black here. It means black box model.
Okay.
Yeah, you are correct. Yeah.
Okay, so difference between C and D is in the explainability.
Yeah, it's an explainable assignment module. Different.
Okay.
For C with D.
Okay. 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 I just wanted to understand this.
Oh yeah. Thank you for the question.
Yeah. Thank you.
Oh here, yeah. Here is different here. So the difference between like AB and CD. Yeah, for the hierarchical IME is add to deep neural network expert, and it's also add to like hierarchical assignment module to explain the contribution of IME and also the contribution of deep neural network. There's a detail of hierarchical IME design. For the loss function, it's concatenated. It's combined of five loss. For predict loss is the overall accuracy of model. For utilization loss, the loss here to utilize the utilize the results between the expert. So because when we change the deep as a mixture of expert, it can be the all inputs will be focused on one expert. So to avoid all sample can be assigned to one expert. They introduce the expert utilization loss and expert diversity. So it's for the case expert should be like diverse prediction and to help the assignment module for better assignment. And for assignment smooth loss, for the input with time information, assignment should be smooth for the consecutive input, and it would be for better generalization and for better interpretability. And the last one is the assignment accuracy. Is like is for the improve the accuracy of assignment module. For detail formula here, for xy is represent for input and output. X hard is like concatenate between feature embedding and also the path error made by expert. For example, here is will be concatenate with the input and the expert errors to assign the weight between each module. And here is for ICAS. And for HW is a function to output the n-dimensional vector represent for weight I. So weight for the weight from I to n here, or weight here will be like sum up or weight. For example, weight 1, weight 2, and weight 3. Sum of this will be 1. So the AW is a function to output that weight to the vector representation for this weight, and for the AY is function to output the y hash to calculate the assignment accuracy. Yeah, it's to calculate the assignment accuracy here. And for both weight I and weight W share the same weight, but the different for the last layer. And for training algorithm, because this framework can be combined both like explainable model like linear regression or decision tree, and it can be combined like deep neural network model. So it's very hard to training the model end to end like the whole deep neural network model. So the author here, they propose like training this model with 2 parts. The first part, this will be train model to minimize the overall loss here. So the loss total here, this will be. So the purpose of this first step here, they want to train the expert to, because the live assignment module is will be focus, which will be depend on the expert capability or expert accuracy. So if when the first training expert is like random weight, and the accuracy of expert is just random, and each expert do not have any knowledge yet. And the first step is the model will be trained for the expert have some like specialized knowledge. And the second step, they will frozen expert, and the assignment module will be trained to maximize the assignment policy. So yeah, this proposal is quite makes sense, because yeah, for the like understanding of like the randomly for the initialize the expert is randomly by weight, and it should be trained to have some basic knowledge first, as based on the knowledge of expert we will freeze this expert, and we change the assignment module to be like the best loss. So it's like design, and the next for the IM is interpretability capability.
Can I ask you one question?
Yeah.
Can you go to the losses figure?
Yeah.
You had a figure that says like this is the loss.
Oh yeah, it's a lot. You mean?
Yeah, this one is fine.
Oh, okay, yeah.
Okay. So here you have the input. You put the.
Yeah, we have a five kind of loss.
I'm trying to understand, like if you have the input, you put it to the expert. Expert makes a prediction. You take the expert error.
That's true. And this we calculate the errors between the expert and targets, and we use this with the input as the concatenate together as the input for assignment module.
And then based on this concatenation, you get the updated weight, right?
Yeah, it is the assignment module is the tool to interpret model.
Okay, and then I'm trying to say, like, for example, the smoothness loss, or so W1, W2, because like I was trying to understand for example, the diversity loss that you have here, right? It is related to the prediction of the experts, right?
Diversity loss here can be used for in the case we want to control the input to each expert is diverse. It's not focused on the one expert.
So if you go to that figure where, so here you can see like it is arrowed from the prediction 1, prediction 2, prediction 3, right?
Yeah.
So it is trying to distinguish between the prediction made by each of the experts, right? So this how you get the diversity loss, and combining them you get the accuracy loss.
You mean for the detail of formula?
Not the formula, not the formula. I'm trying to understand, like, for example, if I'm trying to, what is the purpose of the diversity loss and what is the purpose? That is what I was trying to understand.
The purpose of diversity loss is want to expert is like learn different things. For example, if the expert is learns the similar thing, like it's output for the same result. So it means like we don't need to three expert, for example, like this. So the purpose of this loss the output of expert is a variant, it's different.
Right.
So it's the reason why we have
how difference, or what is the difference between different experts, right?
Yeah, that's true.
Yeah, and so accuracy loss is, I'm trying to understand like the smoothness loss and utilization loss. What is the formulation?
For the utilization loss, we want to this weight is it's not for, like, for example, it's many sample is focused on weight number 1 and weight number 2 and number 3 is 0, and this means like it's only focused on expert number 1 and other expert is learn nothing, and it's for utilization loss. We want to like the x input will be assigned for expert. We not assign all inputs for one expert.
What is the word utilization means in this case?
It can be like for the training mixture of expert, it can be happen a case all inputs will be assignment for one expert. So this case we call it imbalance. We just all input they choose one expert, and to avoid all sample we assign one expert. So we need to have a utilization loss.
Oh, so utilization loss. Can you go to the figure? I'm just wondering if there's a relation between utilization loss and diversity loss.
It's different because it's for assignment, and this one is for the output of predictor. Output of expert is different, and utilization is for the assignment to expert should be equally. We should not like focus on one expert.
Okay.
Yeah, it's a like purpose of this. And for accuracy loss, is the overall accuracy of this model.
Overall accuracy loss based on the prediction and the targets and the model result.
That's true.
And assignment module loss, it takes the prediction made by the assignment, compares it to the target, and that compute the loss, right?
Yeah, it's for the assignment. Is it correct assignment now? Yeah.
And smoothness is to figure out smoothness loss is related to how you update the weights for each of the iterations, right?
Yeah, smooth loss is like same as smooth loss in like classification.
Yeah, I think okay. Yeah, I got it. Okay. Thank you so much.
Okay. Yeah, it's for the training, and the next for the interpretability capability. And they propose like 4 types of IME model, and each type can be different capability. For the single IME K number 8 here. So it's called global interpretable model, and it can be attract the relationship between like input and output, because in this case the assignment module can be explained and we can attract the relation between like input and output. So it's very helpful to explainable for many case, like so the data in medicine or something like, yeah, this can be our statistic is really they really care about the relation between like x and y. And for number B, that this can be like local interpretable. So this can be assessed like expert to assess the feature important of X expert, or we can verify the logic of X expert. And for C and D is hierarchical model, and so the main difference between hierarchical and single is a user pre-trained deep neural network as an expert, and the number of sample that assigned to like deep neural network expert can be controlled by alpha with the EU of the deep neural network, and it's kind of lost when we increase alpha. It can be controlled like how many input we will assign to deep neural network, and it can be used to improve interpretable the decision making to depend on the deep neural network or another expert. And the next for experiment, the model is experiment for the many kind of data, because this module is designed for tableau data or time series data. And firstly, they compare the model with tableau data with the time component. Here they choose the Roseman dataset and with the comparison in root mean square error. And the result report here, you can see that the single IME model is performed better than single interpret model like regression or decision tree, but it's still worse than black box model like XGBoost or like gradient boosting model. But when it's improved in single IME dimension, it's deep neural network is comparable with the black box model. So result is can be compared with XGBoost, and with the hierarchical model is outperform the best model like XGBoost or like gradient boosting, while it's offering the partial interpretability. Why the code is a partial interpretability? Because you can see in the interpretability sample here, it will be show the how many data it can be explainable, because the assignment module will be assigned to deep neural network or assigned to explainable model. So in the case it's assigned to deep neural network, so this data, the code it cannot be interpretability, and in the case it's assigned to interpretable model, the code is like interpretable sample. So it's the reason why the sample here is not 100%. But it's kind of trade-off between like model performance and model explainability. It's called a trade-off. And for the tableau data with time component, they also show that the sample assignment to interpret model and the sample assigned to deep neural network model. And you can see here with like 40% sample assignment to soft decision tree expert is almost no change the accuracy, and it's almost unchanged accuracy. And after it's increased, it can be reduce the model accuracy. But with 40% sample, model still work very good. And for the experiment on the tableau data without the time component, and for the classification task, the single IME model is compared, it can be compared with other model like black box model, like XGBoost or deep neural network. And for regression task, regression state for the regression task, none of the intermodal perform deep neural network on FICO dataset. But however, in other dataset, in like telecom tune or breast cancer or credit, this single IME module only in the second on the second best. For time series data forecasting, this IME model is for the universe forecasting. I mean, outperform black box model. But for multivariate forecasting, this model still not quite well performing compared with like black box model. And in that case, the paper only compare with simple model like transformer or LSTM. Recently, there are many kind of new model in time series forecasting, like past TST or I transformer is the state-of-the-art model in time forecasting, and this paper only compare with the basic model only. And for the explainable, this model, this single IMEs can be very good for global interpretability. So you can see here the algorithm number 2 is a did cover on the electric data set with the time series length is 3 and number of expert is 2. So it can be like formula model as a like a linear equation. So it can be very easy to interpret and make decision based on this model. This kind of like linear regression model output. And for expert in interpretability, so for the this model test on the Rosman dataset is allowed to expert behavior can be easy to interpret. For example, here you can see in the expert number 1 is blue color. It can be high positive weight on the number of customer and the open, and also the feature competition distance. Here is very, and other expert like expert number 2 is orange. This can be positive for number of customer or open. Expert number 3, this can be positive on the number of customer feature. Yeah, it's very positive. And it also can be used for the sample wise expert interpretable. It's kind of like feature important like decision random forest or random boosting model. It can be output for the feature weight to show the which feature is most contribute to our model. So the map as the plot here, so the IME model can be so the feature weight. This can be interpretable linear regression model on the dataset Rosman dataset. And this single IME model can also use to identifying incorrect model behavior. It's very interesting one because like normally we can use this model to detect, but rather it's hard to understand this model detect is correct or not if we don't have like target data. But this method can be used to identify the correct model behavior. The correct here mean like is the consistency model or not. Because for example, we want to the expert number 1 will be assigned to feature number x1, and expert number 2 assigned to feature x2, and expert number 3 assigned to number x3. And in the case we model is not behavior like this. For example, in expert number 1 in a single IME model is incorrect assignment because this assignment larger for feature number x2. So yeah, so it can be helpful for interpreting the different ways and help to verify whether expert is the same logic or consistently or not. Yeah, and it also can be utilized to the chain over time is a different expert. For example, here the capacity of this model can be used to identify or to recognize the time the time chain behavior here for the temporal trajectory and major event chain also. From expert number 2, it can be changed time by time here, so it can be used to get insight or to detect the temporal characteristic or major event chain. For the conclusion, so I see there's some strength or weakness of this paper. For the strength, this paper is the first time proposed an inherent interpretable framework for Tableau or time series data. So this design of combination deep neural network and simple model is explainable model like linear regression or decision tree level is a trade-off between accuracy and interpretable, and to achieve useful like explainable capability. It's also address the four type of model, including single level or hierarchical assignment option. But there are some drawback or weakness of this model. Firstly, the IMF paper is not support for unstructured data, high-dimensional data like image or text. And another like linear regression for expert or assignment module is not entirely novel, yes, because it's just combined between like the existing method like deep neural network and linear regression or decision tree, and this combined together is kind of ensemble model. And the last one is the result is it's not compared to the state of the art model. Yes, it's just compared with the basic model like transformer. Yeah. So that's some key point for this mode for interpretive mixture of expert model. So thank you for listening. Do you have any question?
Questions?